Welcome back to Zero Tolerance and our video series Learn to Burn with Practical Machinist. Today's episode we're going to cover fast hole and wire EDM, and we're also going to have a practical application for these two very powerful tools in our shop. And remember to subscribe and like below. So here's the problem that we're trying to solve with our molding department. And we're going to have to use both fast hole and wire to achieve a solution that we've come up with in the design. So what we have here is an insert that we actually overmold material on. This is the end result, and this is the beginning part that we have to overmold. So we put this in here, and if we look at it from the side, you can see it doesn't stick very well. And as the machine and the molding press moves, these have a tendency to sometimes fall, which has caused damage to the tool, and it causes a big problem when we're trying to mold lots and lots of parts. So our solution for this problem is to create a way to retain the inserts the best way we can in the little space we have to design with. So with our experience, we came up with a way to utilize some ejector pins, which when they're very small, they do have a little bit of flex to it. So we're going to utilize those pins to act like a spring in the design. And this part right here, you can see we have our clearance pockets that we CNC'd in there for these little pins, which we'll show you in a minute as a solution to this problem. All right, the one main thing that we're trying to achieve once we get these to retain in the mold better is we've designed a 3D claw, we call it, that will help load all four inserts at one time. Okay, so here is our design. Here's the insert, the aluminum insert. This is the block, a hardened block of steel. It's S7 and it's 52 Rockwell. And then we have our pins that we designed to act like springs. They have to go 1.5 inches through a hardened block. So in order to do that, we're going to have to fast hole and wire not only the pins, but also the holes through the block. So this is a great application for this technology. Okay, before we get too practical, we have to get technical again about some of the aspects of fast hole or what they call hole popper. Before we can use the wire EDM process, we need to have a start hole. And typically a start hole is put in with a hole popper or a fast hole machine, which uses a copper or a brass rod like the one I have here. And depending on the material you're putting the hole in, you want to have brass typically is used for steel and aluminum, and copper would be used to go through carbide and real harder materials. So the coolest part about the fast hole is it really goes fast compared to drilling a hole. And let's say you had a carbide drill and you were going through hardened steel, it would take a long time, even though it's doable. But as your drill gets a lot smaller, you're more likely you're going to break it. It's going to heat up, it's going to expand and snap inside your block, and then you're going to come to us to get a fast hole to drill out, or broken tap, or whatever needs to be done. But what happens here is deionized water is being pushed through the center of this rod, and typically it's rotating, and it's not rotating very fast, but the fast hole is spinning like a drill. So it's literally a wire EDM drill. So the hole that we want out of there, we want to put a hole through something. If there's a flush line in your rod, it will, sometimes you'll end up with a standing boss in there, and we don't want that typically. So a lot of the better fast hole drills or drill rods for the EDM will have a couple different combinations. Typically they'll have two spots like this, where the center will always cut the little standing boss out of there, so we won't have that problem. Some of the better ones that you can get, they're a little more expensive. They have like a 3-lobe style of flushing through the center, and it's a very high pressure flushing that happens. And it's one thing I didn't explain yet about just EDM in general. The idea of flush is huge. Flush is everything. When I was learning to do wire work and EDM work, conventional EDM, flush was the the name of the game. You had to get flush in your electrodes. I had to drill holes, little tiny drill holes with a Westhoff machine. I would drill into my fingers sometimes. It wasn't fun. But if anyone's ever done it, old school, I call it now, there you drill holes in everything. But today, the newer technology, you don't need that. The fast hole still utilizes it because it goes fast and it's very effective. And the best part about the wiring or the deionized water is the more water-like your flushing can be, the faster the burn will go. So when you have EDM oils in the sinker machine, they're typically a lot thicker than water. So the thinner you can make that EDM oil, the faster the burns will go. And that's the same that's why we use the deionized water in our fast hole, which it does want to rust. So we usually like to get those holes in quickly and get those blocks out of that machine so you don't end up with a lot of rust on the blocks. There's all kinds of sizes you can make with fast holes. I think you can go down to a 7 thousandths diameter up to a 6 millimeter size, which is like a 236 in inches hole with the fast hole machine. Make sure that it's totally square and perfect in the machine before we try to pick up numbers and put a small hole in. So that's what I'm doing right here. I can't stress enough how important that is. We want to make sure we're as flat as we can be. And that is good enough for what we're doing. And we are going to pick up this block to put the fast holes through. So we basically take this fast hole rod and we pick up the center of the block just by touching it. You'll hear a beep. Touch each side and split the difference.
Center.
Alright, that gets us to center. And then we're going to be putting in, 4 holes per cavity.
We do have a couple in already.
Yeah, we got a couple in already, and then we're putting them in on a spot that is, if you've ever drilled a hole in steel and you have to put it on an edge, the drill will wander. Can happen here a little, but it's very, very unlikely it'll be a problem because it's technically not touching. There's the one on the other side, and then this one's going in that spot right there. What size diameter do we have here?
That's a 1 millimeter diameter.
All right. So there's,
you can see
the ionized water going through the center of that.
around the outside to keep it insulated. Pull it down, close.
You see the material coming off there is making the water black. A typical hole like this probably takes like a minute or 2 to go through a block that's about an inch, inch and a half thick. Let's see if we can see it come through. There it goes. As we fast hole these holes in this block, I just want to talk about this fast hole machine is a manual machine like a Bridgeport, where you move the XY to the location you need it to be after you find center of the block. And as anyone knows, it's us being human, we make mistakes sometimes. So mistakes on manual machines are much more common than on CNC machines. So this is one of those machines. Now that we're done with the fast hole, it's time to go to the wire machine. Alright, here's the block and the pin set up in the wire EDM, and they are set up by Dan, our shop expert in the wire department. And it looks like we are just about ready to start doing the pins, and then we'll get into that block. Now that we have the CAD file in Esprit, we're going to make a wire program to no core the holes, which means after we have fast hole, now we go in there and we pocket that out like an end mill and then put the draft on, as you can see right here. So this will end up making our pockets precise and complete. So wire is like essential to us building molds here. We do a lot of inserts, a lot of cavities and cores, and we make interchangeable inserts for different features that may need to be either customized by the customer or modified for fit and function on a plastic part. But the standard wire that's out there, most people use 10 thousandths diameter wire, and you can basically cover a large variety of tooling needs. And I'll talk about the tool of mold making industry because we do a lot of inserts. So a 5 thousandths radius is what will be left in the corners on using a 10 thou wire. And when I say that, I'm talking about these corners on the inside of a pocket. So our wire size is 10 thou, and there's a range. I've seen 2 thousandths to 14 thousandths diameter wire. So 2 thousandths wire takes a very specialized machine. There's not many people that can do it. And 14 thousandths wire, you have to have different diamond guides, and the wire, we'll talk about that. The diamond guides are down here in the lower head and the upper head, and that's what holds the 10 thou wire exactly where it needs to be, and it gets calibrated every time you change those diamond guides out. All right, here in Esprit we have the top yellow is UV and the bottom is XY, the blue. And because we have the fast holes in there now, we can auto thread into each hole and create the not just the pocket but also the draft. As you can see, the wire bends at the diamond guides and goes in a straight line. It's only 1.5 degrees that we're showing there, but it does the job, and it makes the clearance for that spring effect on our pin. We're going to get into the wiring part of the pins. The pins are 1/16 of an inch. They're small diameter, and we are going to put the shape on there. And the best way that we know how to do it is wiring the shape on here. So we're using Esprit. We've brought our solid model into Esprit, and now we're going to make the cuts rough and I believe 3 skim passes, and that will give us the shape we need within 1/2 thousandth of tolerance, and that is how we achieve those. So there is 16 of these pins, and we are going to wire them off out there. There's a lot to cover with wire. You have a consumable wire that you're going through. You have diamond guides that wear out over time, but they're diamonds, so they last quite a while. There's contactors made of carbide that transfer the electricity to, they're like little carbide blocks like this, and the wire actually touches those carbide contactors, and those wear out over time as well. There's a lot of maintenance in wire EDM, but there's also a lot of unattended machining can be done, and you can hit numbers with intents on most things. So I want to also talk about the limitations of the wire machine. For our particular machine, there's a limit on the angle that you can go, how much you can tip the U and V head, which is on the upper, and the X and Y head on the bottom, which is right here. Ours goes up to 45 degrees, which is a big angle. And while we're talking about the angles and the draft that can be put on the wire machine, there's also different wire. I talked about tensile wire, but there's also brass wire that is soft, which you will need to go to 45 degrees, and then there's soft brass, there's half hard they call it, and then there's hard brass. So the soft brass can go 45 degrees. The half hard can go, I think, up to 25 degrees. And the hard brass goes about 10 degrees max, depending on your machine. So the limitations are there, but there's ways to do it. But for each different hardness of the brass, you have to have a different tension. So the wire is not only energized, it's actually pulled in tension. So it's held straight as it's burning. So as you're roughing, there's a different tension compared to when you're finishing. And typically the machine has all that technology in that. So I don't really know exactly what those numbers are, but they're recommendations that get put in the machine by the manufacturer of the brass and the machine that you're running. I do want to talk about the different fluids that you can get with wire EDM. Most people use deionized water. You can get oil or like dielectric fluid for like sinker EDMs. It is more precise. You can get better finishes. It's more accurate, but it's a lot slower. So the trade-off is typically for speed. Most people try to go as fast as they can. Obviously, we want to make money, and if we take too much time, then we don't make money. So if there's something that's very specialized, then I have seen dielectric oil in wire EDMs. But for what we're doing deionized water in both our fast hole and our wire EDM. This mistake here happened in the fast hole, and we went ahead and wired out the rest of it anyway, but now we're headed to the welder. ALWS is our welder, and you have to have a good relationship because mistakes do happen. It's not if, it's when. With any engineering change that you do, there's no guarantee that it's going to solve the problem until you actually prove it out and show that it does work. So stay tuned to next month's episode of Everything EDM Learn to Burn, and you will get to see if this worked or not. Also, if there's any questions you have that we have not covered, feel free to list those in the comments below. The fast hole.
Go.
Okay, before we get into... Dang. Ooh. The wire EDM side of the EDM that we're going to go on. This is not good. Not good. Okay. So wire... I just want to clarify that, like, the wire... Instead of... Can we redo that?